Okay, so in this video, we're going to conclude our discussion of linear programming with a discussion of what we're going to call the simplex method. So the simplex method is going to be the most general way to solve a maximization linear programming problem. We're going to build on what we know from the table method, but we're going to generalize it to more complicated situations. We're also going to go back and add in what we know about matrices. So we talked about how we would row reduce a matrix. We're going to need some of those techniques here in this, what we're going to call the simplex method. So let's go back to that 10th problem one more time. So if you remember what we did with the table method, we took our problem constraints, we converted them to equations using slack variables. So we converted our inequalities to equations, converted the I system to the E system by introducing slack variables. So our first problem constraint, we added in S1, slack variable 1, to represent leftovers. So the decision variables represent resources that we use, and the slack variable represents whatever resources are left over in order to meet our maximum allowed value of 32. So less than or equal to 32 becomes equal to 32 as long as we account for the slack. And then our second constraint, again, we introduce an additional slack variable. We have a maximum of 84 hours to use in that particular constraint. 3x1 plus 4x2 represents what we do use. S2 represents what's left over. Add those for a total of 84. So this is what we used in the table method. We're going to take this, we're going to build off of it. So as part of the simplex method, we're going to add the objective function to that list of equations. What we're going to do first, though, with that objective function is we're going to move all terms to the left side of the equation. The result, taking that, combining that with our E system, is going to be what we call the initial system. So our objective function represents profit, so $50 times the number of standard tenths, $80 times the number of expedition tenths. Take the sum of each of those profit components, and that's going to be the total profit overall. We're going to take that objective function and we're going to move these two terms over to the left-hand side and write them in order. So x1 first, and then x2, and then p. And because these have both been subtracted and moved, we now have a 0 on the other side. So in place of that standard objective function, we now have negative 50 x1 minus 80 x2 plus the p that was already on that side of the equation. That's now equal to 0. So we're going to take that and we're going to add that at the very bottom of the E system. We're always going to list that last. So problem constraint 1, problem constraint 2, and now add to the bottom of that this version of our objective function. This is what we call the initial system for performing the simplex method to solve the linear programming problem. Now notice at the bottom I've still included the non-negative constraints. In order for a solution to be feasible, we know that x1, x2, and then our slack variables all have to be non-negative. Anytime one of those variables takes on a negative value, we know we're in a situation where we can't have actual numbers in a real situation that represent that particular combination. So we're going to take this system, this initial system representing our linear programming problem, and we're going to use this to write an augmented matrix. We're going to have to be really, really careful when we do this, though, just because there's so many variables. So think about how many variables there are now. Now, all three equations contain x1 and x2. That's going to be in every equation. And that's going to be the first column and the second column in our augmented matrix. But we also have three additional variables on the left-hand side of the system. We have slack variable 1 for constraint 1. We have slack variable 2 for constraint 2, and then we also have P, which represents profit. So in addition to those first two columns, which are filled in entirely, we also need a column for S1, a column for S2, and a column for P, because those are additional variables represented in this system. Now I'm going to list them in that order. So S1 occurs in equation 1. I'm going to put it in column 1. The next column, I guess we'll call that column 3. We need S2 in the next additional column, and then we need P in the last column. So notice for those extra variables, the ones that we only see in one equation, we only list a 1 in one location in that column. The other locations are listed as 0. That's because those 3 variables are only represented one time throughout the system. So we end up having something that's going to look like that. It's going to look like what we call the identity matrix, 1s along the diagonal, 0s everywhere else. That's going to be what we see in every augmented matrix that we're going to write. There's our equal sign represented by that vertical line. And then the constants on the right-hand side are going to be 32, 84, and 0. So this augmented matrix is what we call the Simplex Tableau. So Tableau, French for table. This is the table we use to perform the simplex method. Now I'm going to add a little bit on just so we're clear on what we're looking at. So we've got that vertical line. I also want to draw a horizontal line between the top 2 lines and the bottom line. This is to remind us of what is representative of what. So the top 2 lines, remember, those came from that E system. Those are representative of problem constraints. The bottom row came from the objective function. So that is going to have to stay right there. The reason it's going to be helpful to draw that line is so that we're not tempted to move things around. So these equations, these rows, these need to stay where they are, particularly that bottom row that's representative of the objective function. Once we row reduce this, simplify this in the form we need, that bottom row is where we're going to find a lot of our solution. We're also going to use these numbers in the bottom row in order to tell us what to do at different steps in this simplification process. So above and everything else, I want to make sure I label each of those columns so I know what's represented where. That's going to help me in interpreting the solution once we get down to the very end. So I've got this Simplex Tableau. The top 2 rows, again, problem constraints. The bottom row is the objective function. Those numbers along the bottom row are called indicators. So we're going to use those indicators to indicate what we need to do and also when we can stop. So what we're going to talk about now are called pivot operations. Pivot operations are essentially our row operations that we do to change the matrix, but they're specific operations informed by the values of those indicators. So we can do any operations we want except interchanging rows. We can't do that. So what are our operations? Well, we can multiply each row by a non-zero constant, and then we can also add one multiple of a row to another row. That's also going to be a legal operation. We're going to use a combination of those operations with a particular goal in mind. So the goal is to solve for each basic variable, in other words, the ones we're going to base our solutions on in this Simplex Tableau. Now, based on the simplified matrix, we'll talk about how we know it's simplified, how we know we're done. The optimal value of the objective function will also be found. So by putting this matrix into a particular form, not only are we going to find the values that the variables need to take on, but we'll also readily find the value that our objective function is going to take on in order to be maximized. So it's going to be a little bit of work to put this matrix in the form we want, but once it's in the form we want, we can immediately read off the entire solution. So here is the simplex method. So number 1, we're going to start by identifying what we call the pivot element. This is going to be the starting point. This is where we're going to start the reduction of our matrix. How do we determine what the pivot element is? We need to determine, number 1, the column that we're in, and number 2, that the row we're in. We're going to take the intersection of the column and the row. Wherever that column and row intersect, that's going to be the pivot element. So the pivot column, the column we're going to start with, is the one that contains the most negative indicator. So the indicators, remember, those are the numbers along the bottom row, the ones we got from the objective function. We're looking for the one that is most negative. Whichever column has the most negative number at the bottom row, that's going to be the column that we start working with. Now for the pivot row, we're going to reference that column, and in that column, we're going to divide each positive element by the element in the last column, or technically vice versa. We're going to take the element in the last column, divide by that element in that pivot column. That's going to result in a few different values depending on how many rows we have in that column. each of those values, we're going to take those and compare. We're going to take the quotient and compare. We want the row that has the lowest quotient. Whichever row has the lowest quotient after that division, that's going to be our pivot row. So if we take the intersection of the pivot column and the pivot row, that's going to give us the pivot element. Now, just as a note, if there are no positive elements in the pivot column above that row, in other words, we identify that column, it's got the most negative indicator. If all the numbers above that are negative, then automatically we can conclude that this problem has no optimal solution. It means you can't go any further. You can't do anything, and there's no way you can optimize, maximize whatever your objective function is. Okay, so we've gone through the steps to identify essentially where we're going to start all of these operations. Once we know where to start, we're going to perform row operations so that we can make the pivot element a 1. That's going to be the first thing we do, turn that pivot element into a 1 if it's not already a 1. And all other elements in the pivot column become a 0. So that constitutes one pivot operation. In other words, taking that column and clearing the whole column constitutes a single pivot operation. Now, in order to get the 1 for the pivot element, typically we're going to take the row and we're going to multiply by a constant. So we're going to do that type of row operation. We're going to multiply that row by whatever constant would take the number that's currently there and turn it into a 1. We're then going to use that row, multiples of that row, to take every other element in the column and make it a 0. Once we're done with that, we're then going to repeat. So we repeat this test for determining the pivot element. So look for the next column that has a negative in the bottom, or maybe we have more than one. It's possible we could have more than one. We look for the next column with the next most negative element. That's going to give us the pivot column. And then we do the same thing to determine the pivot rows again. We're going to keep going as long as there are negative indicators remaining. So as long as that bottom row has negative numbers in it, we keep pivoting until we no longer have any negative indicators. Once there aren't any negative indicators left, and we've done all the pivot operations, cleared all of those columns, we know we've found the optimal solution. So the basic variables, how do we know what the basic variables are? Remember, those are going to be the ones we base our solution on. Those are the ones that actually impact the values for our linear programming problem. We can identify those by finding the columns that only have a 1 or a 0. So once we do all these pivot operations, it doesn't mean we're going to have a whole matrix with 1s and 0s. On the contrary, more than likely we will still have several columns that have non-0 and non-1 elements. What we're focused on are the columns that have been cleared, the ones that only have a 1 and a 0 in them, or a sequence of zeros. So those are going to be the columns that are going to correspond to basic variables. Those are the ones that are going to actually be assigned values for the sake of our problem. The non-basic variables come from the remaining columns, the ones that have elements other than 1 and 0. Automatically, when we identify those, we're going to assign those variables at the very end a value of 0. So we're not basing our solution on them, so we're going to assign them a value of 0 since they don't actually impact our solution. The maximum value, what we're really interested in, the optimal value of our objective function, is going to be in the bottom right corner. What do I mean by that? Well, if you picture the Simplex Tableau, once we reduce all of this, we do the pivot operations based on those two columns that have negative indicators. The number that's down here in the bottom right-hand corner, that is going to be the optimal value for our objective function. That's going to be where we stop. So once we have all of our negative indicators cleared, we clear the columns that go with those. We can read off our optimal value in the bottom corner, and then we can read off our variable values based on what we have in this far right column. So we're going to do a few examples. Let's start with this problem. So our objective function is going to be p is equal to 10x1 plus 5x2. The goal is to find the maximum value of that particular function and the values of the decision variables that will result in this maximum value. Here are our problem constraints. We're just going to start with two. So 2 variables, 2 problem constraints. First thing we need to do is convert to our initial system. So take that I system, convert it to an E system, and then add in that changed version of our objective function. So we have 2 problem constraints. We're going to convert those to equations by adding in those 2 slack variables. Take our less than or equal to, make it an equal to. So the amounts we use plus the slack, the amounts we use plus the slack, exactly equal to our maximums of 28 and 24. We're going to take the objective function, move the 2 values on the right so that they are on the left. In other words, subtract those 2 terms. So we'll have negative 10x1 minus 5x2 plus the p that was already over there, and that's going to be equal to 0. This has to be the bottom row. So we're going to keep the constraints in order, and we're going to keep that objective function as the bottom row. So I'm going to write in my Simplex Tableau. So each row corresponds to one equation, and then we're going to go column by column. So if I were to label the columns, this is column 1, this is column 2, x1, x2. The additional 3 columns correspond to the additional 3 variables. So the third column is going to be S1, our first problem, slack variable, excuse me. The fourth column is going to be S2, our additional slack variable. And then the fifth column represents P, represents the variable corresponding to profit. Where I have the equal signs, I'm going to place that vertical line representative of that, and then my constants are going to go on the right-hand side of this. So I'm going to draw the lines only that one time, just to save a little bit of time. Once we get to the very end, I'll add those back in. The biggest thing to remember, though, is you cannot interchange rows. So once the rows are placed where they are, they stay there. That bottom row stays the objective function. The first and second row are still the first and second problem constraints in that particular order. So this is our initial Simplex Tableau. This is what we're working off of. So we're going to perform pivot operations in order to simplify this as long as we have negative numbers on the bottom. So that's where we're going to start. Start with the bottom row. We have 2 negative values. So these are our indicators. These indicate what we need to do, when we need to do it, how far we need to go. I'm looking for the most negative one. So in this case, the most negative one is negative 10. That tells me that this is going to be my pivot column. Okay. So the numbers I work off with are going to be based on this column to start with. Now, in order to determine which element I'm going to use, which row I'm going to use, I'm going to take the numbers on the far right, and I'm going to divide each of those numbers by the corresponding element in that pivot column. So I'm going to take 28 and divide it by 4, and then I'm going to take 24 and divide it by 2. So 28 divided by 4 is going to give me 7, and then 24 divided by 2 is going to give me 12. I'm going to take the lower of the 2 quotients. In this case, the lower quotient is going to be 7, which resulted from that first row. So that means the pivot row is going to be the top row. So the intersection of the first column and the first row gives me my pivot element. I'm going to circle it. I'm going to keep that element circled as long as I'm performing pivot operations on that particular element in that particular column. So once I know where I'm pivoting from, I know what my pivot element is, the goal is to take that element and turn it into a 1. And then once we have that element as a 1, we want to clear all the other numbers in that column so that they take on a value of 0. So I want to take my 4, and the goal for the first step is to take that 4 and turn it into a 1. I can do that by multiplying by 1/4. So remember the type of operation we can do. We can take the whole row, we can multiply by a fixed constant. So if I were to take that row and multiply that 4 by 1/4, or alternatively, let's think in terms of decimals just to make our lives a little bit easier. Let's call that 0.25. How do we know that those are the same thing? Well, if I'm multiplying by 1/4, 1/4 is 0.25. So I'm taking every element in that row and I'm going to multiply it by 0.25. The notation I'm going to use to say that is going to be this notation. So here's the constant I'm multiplying. I'm multiplying that by row 1, and then the arrow tells me place the result in this location. So once we do that particular operation, we're going to place the result into row 1, and then we're going to go from there. Now the goal is to change the 4 into a 1, but keep in mind we're multiplying the whole row by this number, which is going to affect all the other elements in the row. We have to track what's happening to all the elements, not only what's happening to the one we're hoping to change. So every single number in this row is multiplied by 0.25. So just to verify, let's track everything in the calculator as we go. So 0.25 times 4, okay, that gives us the one we want. So I'm taking this particular row, multiplying by 0.25. For the next operation, that's going to go into that top row. So 0.25 times 4 is going to give us 1. I'm multiplying 0.25 times the other elements as well. So 0.25 times 1 gives me 0.25. So same thing for those two. Now anything times 0 is just going to be 0, so those two top elements are still 0. And then 0.25 times 28, don't forget to do the same thing on the far end, is going to give me 7. So that's going to be 7 right there. I only want to do one operation at a time. So each time I do an operation, I want to rewrite what's left. So row 1 has now changed, but because we only did one operation and it only applied to row 1, rows 2 and 3 haven't changed yet. They're still the same. So that's just copy and paste. Yes, it's a little tedious to have to rewrite everything, but if you try to do more than one step at once, the likelihood of you making a mistake is pretty high. So you want to be really, really careful. Just do one operation at a time. Okay, I kept that pivot element circled because I'm still using that element to clear the column. So the goal now that this is a 1, the goal is to get zeros underneath that 1. In other words, clear the 2, make it a 0, and clear the -10 and make that a 0 as well. I have to use this 1, use a multiple of the 1 in order to clear the remaining 2 elements below it. So if I want to eliminate a 2, think in terms of addition, elimination. What would I have to add to a 2 to eliminate it? Well, I'd have to add a -2 to it. So if I were to take the first row and multiply that row by a -2, and then use that to combine with the second row, that's going to take that 2 and it's going to clear it and it's going to give me the 0 that I want. So my next step is going to be -2 times row 1 plus row 2, the row I want to clear, and I'm going to take the result and put it in row 2. Now, one distinction we need to make, I'm using a multiple of row 1, but I'm not actually changing it. I'm just using this in order to combine with row 2. The only row that changes, though, is the one that's on the other side of the arrow. So I'm adding to row 2 in order to change row 2, but row 1 itself is not actually going to change. I'm going to use a multiple of it temporarily, but I'm not actually going to change it. So it's not a bad idea as you go from step to step. Go ahead and rewrite the rows that aren't going to change. So notice as you go from this step to the next, the only thing that's changing is row 2. So automatically I know I could go ahead and recopy row 1, and I can go ahead and recopy row 3 because those 2 rows are not changing based on the operation we're doing. That's optional. You can wait on those if you want, but if you want, you can go ahead and copy those down because you know they're not changing. So we're taking -2 times each element in row 1 and adding to the corresponding element in row 2. Now the goal was to eliminate this 2 and make it a 0, but keep in mind this is also going to affect the other elements in this row, so we need to determine what's going to happen to all of those as well. So we're going to go element by element. Let's see, let me make sure you can actually see this. Okay, turn it on, clear it. Okay, so we're taking -2 times row 1 and adding it to row 2. So let's start with the first element. So -2 times 1, and we're adding it to row 2, so +2. Okay, and sure enough, that's 0, so it gives us the 0 we want. Now we have to do the same thing for every other element in the row combined with row 2. So -2 times 0.25, and that's being added to the 3, so plus 3, and that's going to give me 2.5. Now, we're taking negative 2 times 0.25 times 0.25, and then we're adding it to 0, so plus 0. That's going to give me negative 0.5. Okay, let me scoot this down. Let's do these other ones mentally. So negative 2 times 0, well, that's just going to be 0. Add it to 1. 0 plus 1 is just going to be 1, so nothing changes there. Once you get to the columns with the zeros and ones, a lot of it you can do mentally. Negative 2 times row 1 is going to be 0, plus row 2, which is 0, so 0 plus 0 gives me 0. And then the last row, so let me move this over for the last column. So negative 2 times 7 plus 24 is going to give me 10. So that's going to go right there as a 10. Okay, so we still have our 1. Notice that didn't change, but we use that 1 to clear the 0 in the second row, to clear that 2 and make it a 0. Well, now we need to clear the 10 at the bottom. In order to clear a negative 10, we would need a positive 10. So if I take 10 as a multiple of row 1 and combine it with row 3, then that's going to give me what I want. Now it's on the next page, so let me just do this in the calculator and we'll track it and then I'll flip it over. So we're multiplying row 1 times a 10, and then we're combining it with row 3, and we're replacing row 3 with that result. So we're going to go element by element. So 10 times what's in row 1, which is 1, plus what's in row 3, which is negative 10, so plus negative 10. Okay, that's going to give us the 0, so first entry is going to be a 0. Okay, next one, 10 times 0.25, and we're adding it to the negative 5 in the bottom row, so plus negative 5. Okay, that's going to give us a negative 2.5. Next one, 10 times 0.25, plus what's in the third row, which is 0. Let's see, that's going to be a 1. Let's clear that. 10 times 0.25. As you can notice, there's quite a lot of room for mistakes, so be careful as you go. Reread what you type in, like I need to do. Okay, so 10 times 0.25 plus 0 is going to give me 2.5, so the new entry there will be 2.5. Okay, let's look at the last ones. We can probably do the next two mentally. So 10 times row 1 is going to be 0, plus row 3, which is 0. So 0 plus 0 is going to give me 0, so this entry will not change. 10 times 0 is 0, plus row 3, which is 1. 0 plus 1 is going to be 1, so this entry won't change. And then 10 times row 1, so 10 times 7 is going to be 70. 70 plus 0 is going to be 70, so this bottom entry is going to be 70. So let's see what it should be before we flip over. So we should have a 0, negative 2.5, 2.5. These two didn't change. And then the last one we determined, 7 times 10 is 70, plus 0 is going to be 70. So that will be what we have once we flip over. So 0, let's check it. 0, negative 2.5, 2.5. These two didn't change. And then we have a 70. Okay, now notice we have cleared that column. So that constitutes one pivot operation. We choose that element, we clear its column, that is a single pivot operation. We have to keep going as long as there are negative numbers along the bottom row. So notice that number along the bottom row that's still negative, it's not the original negative. So the original negative we had was a negative 5. But based on the pivot operations, right there at the end, we changed it so that it's now negative 2.5. Now that's the only negative indicator we have, which means automatically that's going to be the pivot column. Now I need to pick the pivot row. So I'm going to take the two elements on the far right and divide them by the numbers, the corresponding numbers in that pivot column. So 7 divided by 0.25. and 10 divided by 2.5. So 7 divided by 0.25, well, that's 7 divided by a number that's smaller than 1. The result of that is a number that's going to be bigger. So 7 divided by 0.25 is going to give me 28, and 10 divided by 2.5 is going to give me a 4. So because the lower quotient came from the second row, the second row is my pivot row. So pivot column, pivot row, they intersect there at that 2.5. So that is going to be my pivot element. That's the element I want to transform into a 1, and that's the element I'm going to use to clear the column. Now, how do you get rid of a 2.5? Well, if you think about what happened with the first time we cleared, I wanted to get rid of a 4, so I used a 1/4. We call that a reciprocal. If we take any number and multiply it by its reciprocal, then they will clear, they will reduce, they will give you a 1. We don't have a whole number right here, but it doesn't matter. Think about the reciprocal of that. If the number we want to clear is 2.5, then its reciprocal is 1 over 2.5. Is that pretty? Is that proper? No, not really. You don't want to have a decimal inside of a fraction, but we're using this as just a means to an end. So we can use this as the reciprocal. If we take this row and multiply it by the reciprocal of that number we want to clear, it's going to take that number and it's going to convert it to a 1. And then, of course, as with any operation, we have to apply that operation to the entire row. So I'm going to take 1 over 2.5 and multiply it by the elements in that row. So let's do that in the calculator. Now 1 over 2.5 times row 2. Well, let's look at the first element. It's 0. Anything times 0 is still 0, so notice that's not going to change. It's good that it doesn't change, because this row, or this column, I should say, this was the one we started with to clear. We want this to stay cleared. None of the operations we do should take this column and change it. Anything we do is going to keep this column intact. The only things that should change are going to be the columns that are subsequent. So we're going to take 1 over 2.5 times row 2. So times 0 is going to be 0. Now we're multiplying it by the next element. So 1 divided by 2.5 times 2.5 is going to be 1. That was the goal. So that's going to convert to a 1. So let me move this so we can see what happens. Okay, now we're going to multiply by the next element, negative 0.5. So 1 divided by 2.5 times negative 0.5. And that's going to give us negative 0.2. Okay, 1 divided by 2.5 times 1. Well, anything times 1 is itself, so what we want to know is just what is this number. So 1 divided by 2.5 times 1 is going to be 0.4, so that's going to be the next entry in the new row 2. 1 divided by 2.5 times 0. Well, anything times 0 is just 0, so that's still going to be a 0. And then 1 divided by 2.5 times 10. 1 divided by 2.5 times 10 is going to be 4. Okay, so that's my new row 2. Now again, the only thing we arrowed over to was row 2, so that's the only row that changes. Row 1, row 3, those are just copy and paste. Those 2 rows don't change. The only thing that changed during that step was row 2. So I now have my new row 2. My pivot element has been converted to a 1. I want to take that pivot element, use that 1, and clear the number above it and the number below it, convert those to a 0. Well, how do I do that? Let's start with the one above it. We have a 0.25, and we want to take that and reduce it to 0. Well, the only way you could take 0.25 and reduce it to 0 is to subtract 0.25. Or, more appropriately, think of it as adding negative 0.25. So if I had a negative 0.25 to combine with this, then this would reduce down to a 0. So I'm going to use the row with my pivot element. I'm going to take a multiple of that row. I'm going to multiply that row by negative 0.25, by the number I need to clear that particular element and make it a 0. So every element in this row is going to be multiplied by negative 0.25, and then I'm going to add the result to what's in row 1. And I'm going to replace row 1 with that result based on what I wanted to clear. We'll definitely need to do this one in a calculator, so just go step by step, take your time. Now again, the only row changing is row 1, so you might want to recopy row 2 and row 3. That's really up to you. You may just want to wait till the end to do it. Again, that's your choice. Okay, so we're going to take negative 0.25, multiply it by what's in row 2, and then add it to row 1. So negative 0.25 times 0 is 0. Okay, 0 plus row 1, which is a 1. 0 plus 1 is going to be 1. So I'm going to leave that in row 1. Nothing changes. Again, that's intentional. The pivot column that we already cleared should not change. Now we're going to look at the additional columns. So 1, so negative 0.25 times 1, negative 0.25 times 1. Okay, and then we're adding that to what's in row 1, which is 0.25, so plus 0.25. And that's going to go to 0, which was the goal. The goal was to take this, clear this element above it, and turn it into a 0. Now we need to do that same step for everything that's left over. So next element, negative 0.25 times negative 0.2. So negative 0.25 times negative 0.2. And then we are adding that to row 1, so plus 0.25. And that's going to give us 0.3, so that's going to be the next replaced entry. Okay, next column, now we're looking at that 0.4. So negative 0.25 times 0.4. Negative 0.25 times 0.4. And then we are adding that to row 1. So plus 0 is going to be negative 0.1. Let's see if we can do the next one mentally. Negative 0.25 times row 2, so times 0, plus row 1, which is 0. 0 plus 0 is 0, so that element doesn't change. Now, negative 0.25 times 4, negative 0.25 times 4, plus row 1, so plus 7. And that's going to give us a 6. So that concludes that operation. So we have our pivot element converted to a 1. We cleared above it. Now we need to clear below it. So I want to clear a negative 2.5. In order to clear a negative 2.5, I would need to combine it with a positive 2.5. So just like the operation above, I'm going to take that pivot row and I'm going to use the pivot element and take the correct multiple of it to clear the number we want to clear. So I'm going to take row 2, multiply it by a 2.5, add that to row 3, and then take that result and replace row 3. Now what's not going to change here? Row 1's not going to change and row 2 is not going to change. We're using row 2 artificially, but the actual values for row 2 from one step to another are not going to change in this case. So what about the first elements in that row? So we're taking 2.5 times row 2. So 2.5 times 0 is 0, plus row 3, which is 0. So 0 plus 0, well, that's still 0, so that's not going to change. Next column, 2.5 times row 2, which is 1, so times 1, plus row 3, so plus negative 2.5. And that's going to give us 0, which was the intent. So there's our 0. Okay, next one. So negative 0.2 times 2.5. So 2.5 times negative 0.2. Okay, plus the number in row 3, which is 2.5. So plus 2.5. And that's going to give me a 2. Okay, next one, 0.4. So 2.5 times 0.4. Add it to the element in row 3. So plus 0. And that's going to give me a 1. Okay, the last one, or the next to the last one, we should be able to do mentally. So 2.5 times row 2, which is 0. 2.5 times 0 is 0. 0 plus row 3, which is 1, is going to be 1. So that element is not going to change. And then the last column, so 2.5 times row 2, 2.5 times 4, plus row 3, so plus 70. That is going to give us 80. Okay, so first pivot column was cleared, second pivot column was cleared. check your bottom row for any indicators, looking for negative numbers. Now that the whole bottom row is non-negative numbers, that's our indication that we're done. So this is a fully reduced matrix. So I've put back in my lines. I'm going to label my columns. So X1, X2, S1, S2, and P. I want to identify my basic and my non-basic variables, and I also want to identify the optimal value of the objective function. So what I'm looking for in terms of my variables are going to be the columns that have just ones and zeros. So notice we have 3 of them. The first 2 columns are all ones and zeros. So that means X1 and X2 are going to be basic variables. Always, always the last column, or the next to last column, the one to the left of the vertical line, is going to be zeros and ones. That's the column representative of P. P is the value of our objective function. So always we're basing our solution on that particular column and that particular value. So this one will always have zeros and ones. Now S1 and S2 have other values other than 0 and 1. So these are going to be our non-basic variables. Automatically, we're going to assign those 2 variables a value of 0. Now the ones that are basic, we can read off the solution by identifying where the 1 is. So if we look in the X1 column, here's our 1. Follow it across to the number on the far right. These are going to be the values, just like when we do reduced row echelon form in the calculator. We can essentially trace it across from where we have a 1 to the value in the far right-hand column. So that means X1 is going to be 6. And then if we look at the next column, here's the 1 for X2. That means X2 is going to have a value of 4. And then the last one we have is going to be the bottom one down here. That represents P. So that means P is going to be 80. That is our optimal value for our objective function. It's down here in the bottom corner. So P is going to be maximized with a value of 80 when we allow X1 to be 6 and when we allow X2 to be 4. And then the other 2 variables, in this case the slack variables, we're going to assign a value of 0. So that's going to be our optimal solution. Now again, this is kind of tedious. If you felt like the table method was tedious, this is maybe a little bit more tedious. There's a lot of room for mistake here, just simple arithmetic errors. If you make one mistake, it will propagate through the rest of the problem. Being organized, keeping that record of the steps that you've performed is going to be very, very important. Use your graphing calculator strategically here. Make sure as you go line by line that you actually type it in. Don't try to do too much in your head, particularly when you're multiplying by fractions or decimals. Do the multiplication you need and then do the addition you need in your calculator in order to keep yourself from making silly mistakes. Now the good news about the simplex method though is once we get to the end, there's no check this answer, figure out which one's higher. Automatically, the simplex method, that final tableau, has told us what the solution is, what the optimal value for our objective function is, and what the decision variables should take on as values, and what the slack variables should take on as values in order to get that optimal value for the objective function. So we're going to do a couple more. Let's look at this one. So we want to maximize P is equal to 6x1 plus 3x2, subject to these constraints. So negative 2x1 plus 3x2 is less than or equal to 9, and then negative x1 plus 3x2 is less than or equal to 12. Okay, start by writing the initial system, which means take our I system, convert it to an E system, add in our slack variables, take your less than or equal to, make that an equal to. So resources we use plus leftovers are equal to 9, and then resources we use plus leftovers are equal to 12. Convert your objective function into the correct form. So move your terms on the right-hand side over to the left by subtraction, leaving the 0 on the right. So we have negative 6x1 minus 3x2 plus p is equal to 0. Okay, we put those into our matrix in that particular order. So row 1, row 2, row 3. x1 and x2 are represented in all 3 equations. And then the additional 3 variables we only have in one of each of the equations. So those each correspond to their own column, and we have 1s and 0s there. Okay, so once we have our initial Simplex Tableau inputted, we start by identifying our pivot elements. So start with the pivot column. We're looking for the one that has the most negative element along the bottom row. So here's our 2 indicators. The most negative indicator is -6. Okay, so now we know our pivot column. Then we want to determine the pivot row. So I'm going to look at the numbers above. Notice we have a -2 and we have a -1 above. Once I see these, that's actually a red flag in this situation. The fact that we have negative numbers, all negative numbers in that pivot column, is actually an indicator that there is no optimal solution. So we start by identifying that pivot column. If we can't find non-negative numbers above it, automatically that means there's no optimal solution. It means you don't have to do 9 divided by -2 and 12 divided by -1. Doesn't matter. As long as the pivot column has only negative values, it's our indication that there is no optimal solution. In other words, this particular combination with this objective function and these constraints can't actually be optimized so that we can find a maximum value. What it means more than likely is that the value for profit could continue to increase indefinitely. There is no maximum x1 and x2 that result in a highest value for P. P can keep going, P can keep maximizing indefinitely. So we don't have to do anything, we just move on to another problem. So let's look at the last one. I've added on an additional problem constraint just so we can see what this looks like. Again, don't be overwhelmed, just stay organized. As you go step by step, think about which rows do change, which rows don't change. Just try to stay as organized as possible. So we still have only 2 variables, but now we have 3 problem constraints, which means we need 3 slack variables. So slack variable 1, slack variable 2, and slack variable 3, and then we convert to our e-system. Take our objective function, subtract the 2 terms on the right to move them to the left, and then that's going to be the bottom row for our system. Okay, so this system is going to need 4 rows, and then we have 4 additional variables, so we'll need 4 extra columns above and beyond the x1 and x2 columns. 1 for s1, 1 for s2, 1 for s3, and then for p. So here's our x1 column, x2, s1, s2, s3, p, and then here's the bar indicative of our equal signs, and then the constants on the right hand side. So we have our 3 problem constraints, and then on the bottom we have our objective function. Okay, let's start with the pivot column. So I'm looking along the bottom row. I have 2 negative indicators. I want to start with the most negative number, which in this case is -20. So that means this is going to be my pivot column. I'm looking at the numbers above it. They're non-negative numbers, so that means I can pivot in this column. I want to take each of the numbers on the far right and divide by the corresponding element in the pivot column. So 10 divided by 2 is going to give me 5. 6 divided by 1 is going to give me 6. And then 9 divided by 1 is going to give me 9. The lowest among those quotients is going to be the 5. So I'm going to take the row that gave me that particular quotient. So that's going to be my pivot row. So pivot row intersected with pivot column tells me that 2 is going to be the pivot element. So that's going to be the element I convert into a 1, and that's going to be the element I use to clear the rest of the column. Okay, so the first thing I want to do is take that 2 and make it a 1. I can always multiply that row by the reciprocal of the number I want to clear. So I want to clear a 2. I'm going to clear that 2 by multiplying the row by 0.5. So I just recopied, nothing happened from here to here. I just identified the pivot element and then recopied it, and we're going to pivot from that particular element. So I want to convert this 2 to a 1, so I'm going to take row 3 and multiply it by 1/2 or by 0.5. So let's do that in the calculator. So everything in row 3 times 0.5. So 0.5 times the 1, times 1, is going to give me 0.5. So that's going to be the first element in the new row 3. 0.5 times 2. That's going to be my second element. Now let's look at the other one. So 0.5 times 0, that's just going to be 0, so that element doesn't change. 0.5 times 0, also 0. 0.5 times 1, just 0.5. Notice it's the same as the one we did first. 0.5 times 0, again, that's going to be 0. So these two elements, this element, those aren't going to change. This is going to be a 0.5. And then the last element in the row, 0.5 times 10, is going to give me 5. Row 1, row 2, row 4, those are not going to change. So that's just going to be copy and paste as we go from one tableau to the next. Okay, so those were copy and paste, and then we had our 0.5, we have our 1, those didn't change, that became a 0.5, and then our last element was 5. Okay, so our pivot element is now the one that we want. We want to use this to clear everything above and then clear that negative 20 below. Let me scoot up. Okay, so let's start at the very top. We want to make this element a 0 using our pivot element. So I want to cancel out a 1 and make it a 0. What would cancel a 1 is a negative 1. So if I take this row, my pivot row, and multiply that row by a negative 1, and then combine it with row 1, that will clear that element, and that will make that element a 0. So I'm going to take negative row 3, negative 1 times row 3, plus row 1, and I'm going to put the result into row 1, replace that row. So let's go through and do each of those. So negative row 3 plus row 1 into row 1. So negative row 3, negative 0.5, plus row 1, so plus 2, into row 1. So there's that 1.5. That's where that comes from. Negative row 3, so negative 1, plus row 1, so plus 1, is going to give me 0. That was the goal, to get the 0 right there. Okay, let's look at the next one. Negative row 3. Negative 0 is just 0. Well, 0 plus 1 is still just 1. So that element doesn't change. Negative 0 plus 0 is still just 0. So that one doesn't change either. Negative 0.5 plus 0 is going to be negative 0.5, so that goes there. Okay, negative 0 plus 0 is still 0. And then negative 5 plus 9, if you want to just be safe, negative 5 plus 9 is going to be 4. So that's going to be the last element in that row. Okay, so that row is cleared in the pivot column. Now I want to clear the 1 right below that. Same operation, but now we're combining with row 2 instead of with row 1. So negative row 3 plus row 2, and put the result into row 2. So negative 0.5 plus row 2, so plus 1, is going to give me 0.5. So there's that element. Okay, negative row 3, so negative 1 plus 1, negative 1 plus 1 is going to give me 0. So there's that 0. Okay, negative row 3, so negative 0 plus row 2. Well, negative 0 is 0, plus 0 is still 0, so that didn't change. Negative 0 plus 1 is just going to be 0 plus 1, which gives me a 1. Negative 0.5 plus 0 is going to be negative 0.5. Negative 0 plus 0 is going to be 0. And then negative 5 plus 6, negative 5 plus 6 is going to be 1. So that element becomes a 1. Okay, so that clears that additional 1 above our pivot element. Last but not least, we need to clear the indicator on the bottom. So if we want to convert a negative 20 to a 0, we need to reduce it to a 0. We need to add a positive 20. So we're going to take our pivot row, multiply the pivot row by 20, whatever we need to eliminate that negative number, and then add the result to row 4, put the result into row 4. Okay, so Row 1, row 2, those are not changing. We're going to leave those. You can just copy and paste those. We're not technically changing row 3. We're using it in order to change row 4. So 20 times row 3 plus row 4 into row 4. So let's start over here. So 20 times 0.5, 20 times 0.5 plus row 4, so plus negative 15, is going to give us negative 5. Okay, next one. 20 times 1 plus negative 20 is going to give us the 0 we wanted. So there's that 0. That clears that particular column. Now we need to keep going and see the impact for the rest of the row. So 20 times row 3, 20 times 0 is 0. 0 plus 0 is still 0, so that element doesn't change. 20 times 0 is 0 plus 0, again, still 0, same effect. 20 times 0.5, 20 times 0.5 plus 0 is going to be 10, so that's going to be 10 in that particular column. 20 times 0 is 0. 0 plus 1 is 1. And then at the very end, 20 times 5, 20 times 5 plus 0 is going to be 100. So the bottom right-hand corner is now 100. Remember that bottom right-hand corner represents where we're going to find the maximum value for the objective function. So far, the objective function is maximized at 100. But we now need to check for any additional needed pivot operations. So in this case, our pivot column is cleared. Now we see if we need to pivot again. As long as we have negative numbers along the bottom row, we need to pivot again. So we have, in this case, a negative 5, so the negative 15 reduced to a negative 5. This is the only negative indicator, so this is going to be the pivot column. I'm going to check for the pivot row by dividing each element on the far right by the corresponding element in that column. So 4 divided by 1.5 is going to give us 2.7. 1 divided by 0.5 is going to give us 2. And then 5 divided by 0.5 is going to give us 10. So the smallest quotient is in the second row. So the second row is going to be my pivot row. So take that intersection. That means our pivot element is going to be that 0.5. So this is going to be the first element we want to convert to a 1, and then we'll use that to clear the rest of the column and convert that to zeros. Now again, we can always just multiply that row by the reciprocal of the number we want to get rid of. So the reciprocal of 0.5, one way to write it is just 1 over 0.5. So if we multiply that row by 1 over 0.5, then we'll convert our pivot element to a 1. So let's do that. So 1 divided by 0.5 times 0.5, sure enough, turns it into a 1. Now the next one's 1 divided by 0.5 times 0. Well, anything times 0 is 0, so that's not going to change. That one will still be a 0 when we flip over and look at the next matrix. 1 divided by 0.5 times 0, again, is 0. 1 divided by 0.5 times 1. 1 divided by 0.5 times 1 is going to be 2. So that next element is going to be a 2. 1 divided by 0.5 times negative 0.5. 1 divided by 0.5 times negative 0.5 is going to be negative 1. So this element will convert to a negative 1. 1 divided by 0.5 times 0 is 0. And then 1 divided by 0.5 times 1. 1 divided by 0.5 times 1. Technically, we already did this one above. That's going to convert to a 2. So let's flip over and let's see what that looks like. So again, row 1, row 3, row 5, those have, or row 4, those have not changed. The only thing that changed was row 2, and now our pivot element is a 1. So let's start by clearing above, getting that 0 in the row above that. We want to eliminate a 1.5, so we need a negative 1.5. So I'm going to take row 2, my pivot row, multiply it by negative 1.5, and then take the result and add it to row 1 and replace row 1 with that in order to get that 0 that we want. So negative 1.5 times row 2 plus row 1. So negative 1.5 times row 2, so times 1, plus row 1, so plus 1.5. And that gives us the 0 that we want, so there's that 0. Okay, negative 1.5 times row 2. Well, negative 1.5 times 0 is 0. 0 plus 0 is 0, so that didn't change. Negative 1.5 times 0 is 0, plus row 1, which is 1. 0 plus 1 is 1, so that also didn't change. Next one, negative 1.5 times 2. Negative 1.5 times 2 plus 0 is going to be negative 3, so there's that element. Negative 1.5 times negative 1. Negative 1.5 times negative 1 plus negative 0.5 is going to be 1. So negative 0.5 becomes a 1. Negative 1.5 times 0 is 0. Plus 0 is still 0, so that doesn't change. Negative 1.5 times 2 plus 4 is going to be 1. So that'll be the last element in that row. So that's going to clear the 0 above our pivot element. Now we want to clear and get that 0 above or below. So we have a 0.5. We need a negative 0.5 to cancel that. So multiply row 2 by negative 0.5, combine it with row 3 to clear, and then put the result into row 3. Okay, so let's do that one. So negative 0.5 times 1, and then we're combining it with the 0.5 below. So plus 0.5 is going to give us the 0 that we want right there. Okay, negative 0.5 times 0 is 0. Plus 1 is going to give us 1, so that element doesn't change. Negative 0.5 times 0 plus 0. Well, 0 plus 0 is going to give us 0. That element doesn't change. Negative 0.5 times 2. So negative 0.5 times 2 plus 0 is going to give us negative 1. So that element is going to be negative 1. Negative 0.5 times negative 1. Negative 0.5 times negative 1 plus 0.5 is going to give us a 1. Negative 0.5 times 0 is 0. Plus 0 is 0. So that one doesn't change. Negative 0.5 times 2 plus 5 is going to give us the 4. So row 3 now replaced by the result of that particular sequence. Last but not least, let's clear that negative 5 at the bottom. So to clear a negative 5, we need a positive 5. So I'm going to take positive 5 as a multiple of that pivot row, and I'm going to add it to row 4 and replace row 4 with that new result. So row 1, row 2, row 3, those rows are not going to change in this step. So again, if you want to copy and paste, put those in, you can do that. So 5 times row 2 plus row 4. So 5 times row 2, 5 times 1, plus row 4, so plus negative 5, is going to give us 0, which was the goal. Okay, 5 times 0 is 0. 0 plus 0 is 0, so nothing changed there. That's not surprising. Notice that particular column didn't change at any point here. That's because that was our prior pivot column. In that case, the pivot column, once it's cleared, it's going to stay that way. It's not going to change. The only other columns that'll change will be the non-pivot columns. Okay, so let's keep going. 5 times 0 is 0, plus 0 is 0, so that element doesn't change. 5 times 2 is going to give you 10. 10 plus 0 is going to be 10. 5 times negative 1 is negative 5, so 5 times negative 1. And then we're adding that to 10, so plus 10 is going to give us 5. 5 times 0 is 0. 0 plus 1 is going to give us 1. So notice that column also stayed the same. The first one we worked through, that column didn't change at all. That column will never change. So if for some reason you go through your row operations and something changes that last column, that means you've made a mistake. It means you need to go back and check your work. It means one of your operations was executed incorrectly. Okay, last column. So 5 times 2 plus row 4, so plus 100, is going to give us 110. So that's going to be the last element. There we go. Okay, so we cleared the first row, our current pivot, or first column, our current pivot column. We've cleared the second one. I look at my bottom row, no more negative indicators, so that means we're done. So my basic variables are going to be the ones represented in columns that have only zeros and ones. So the X1, X2, and S1 columns only have zeros and ones, as does the P column. The S2 and S3 columns have non-zero and non-1 elements. So I know these are going to be my non-basic variables. I'm going to set those values to 0. The other values I can read off across the row. So the first one I see is right here. So if I follow that across, we know that S1 takes on a value for 1. So notice here, the slack variable, the first slack variable, was actually one of our basic variables. This is something that hasn't happened for us before. What that means is that in order to optimize the situation, we actually do need some slack. For the first problem constraint, we actually need 1 bit of slack, 1 element of slack, 1 unit of slack, whatever our units are in our situation, in order to get the optimal value for P. So sometimes slack will be useful. Using all your resources isn't always going to optimize the situation, and in this case it didn't, because we actually do have some slack included. So S1 is going to be 1. Well, here's the next one. So X1 is going to be 2, and then X2 is going to be 4. So X1 is 2, X2 is 4, and then S1, our slack variable 1, is 1. Slack variable 2, slack variable 3, the ones for the second and third problem constraints, those also take on a value for 0 because those are non-basic. And then our optimal value for P, our maximum value for P, is going to be 110. So that is going to be the maximum value in this situation. Okay, so that is the simplex method. The simplex method, yes, it's tedious. Yes, it takes a little bit of time. There is room for error. There's not a lot of room to just do this on your calculator because you're not completely row reducing. You're not completely reducing into reduced row echelon form, not necessarily. So some of this does have to be done by hand, unfortunately. But the good thing about the simplex method is it's generalizable. In terms of the table method, we're kind of limited as to how many problem constraints, how many variables we can have. The more variables and problem constraints we have, if we adjust the table method becomes very, very tedious to execute. So in that case, if we were to expand the problems we're looking at with the table method, they become ones that really aren't manageable, and the simplex method ends up being easier than the table method. We can also technically graph systems that have more variables and more problem constraints, but then we run into the risk of having to graph in 3 dimensions or maybe even 4 dimensions, and it's difficult to visualize situations like that. So the simplex method is going to be the most generalizable approach to linear programming. So we have 3 techniques we've looked at. We looked at graphing, we looked at the table method, and now we've looked at the simplex method. All of these are going to be good options in different situations for solving these type of optimization problems.